So is it live? There's a lot that's wrong here. Oh, is it live? Oh yeah. Is it live? Oh yeah. Alright, now to get the audio right.
Okay. All right. That's better. Okay, testing sound again. I think my sound's okay. Sound is good, right? All right. Let's see. I think I am. I think I'm streaming this. Maybe. Kind of exciting. Oops. All right, let's see here. So, if all goes well, we should see this pressure number start spiking in like 3 minutes. We'll see if it actually happens. I don't know how accurate my calculations are here. But I did a little script where, given this history, this is the history of the last few days. The first pressure wave came through at 4:33 a.m. Yesterday morning, and it was pretty obvious. And then the second one came through here just around midnight that day. And so that's basically this first one is the direct shot from Tonga straight to Seattle, and then the other one is like the opposite direction because the pressure wave was going around the world and it came a lot longer and then crossed at this later time. And so I wrote this little script. Let's see if I can pull it up. Sorry. Edit. That basically just took the time of the eruption here in UTC time, and then I typed in the time that wave 1 came through and wave 2, and I did the sort of the beginning of the peak going up, so that if I'm sitting here, I'm hoping the idea is we'll start seeing it spike around that time. So then I got the coordinates of where the eruption was and where I am. And so I computed the distance between those and then just computed the time deltas, wave 1 versus eruption. So these are the times in seconds. These are the distances. So of course you can compute the speed. And so I computed the speed of the wave and sort of took the average of the two, just assuming that would be most accurate. And then I made a loop 7 times and just said, okay, after wave 1, give me the circumference of the Earth times how long it's going to take the wave to come back around. So it's just the loop number divided by the speed there. And so then that gave these results, which sort of predict, here's the first one, short way and long way. So those are the ones that were kind of measured already. And then these are the predictions. So here we are. It's now January 16th. It's it's the time right now. So we should start seeing it going up. 15:53. So let's see. now the long waiting period begins, and maybe we won't see anything. Who knows? We do know that when Krakatoa went off in 1883, that the pressure wave was actually measured like 7 different times going around the world, which is kind of crazy. This hasn't actually updated for 16 minutes, which is kind of concerning. I think that just means it's stable. Just double check. My pressure updating. Come on, wave. Yeah, those are synced up. Let the waiting game begin. And, I could have messed the math up also. That is certainly an option. And there's some, the speeds of the waves were a little bit off. And the speed of sound changes a little bit based on temperature and elevation and other things. And so as it goes around the world at one time, more than one time in this case, maybe the, oh geez. Did we get a spike there? Maybe the pressure goes up a little bit. We have seen just now, right on schedule, we've seen like a small, tiny increase. And this sensor is updating roughly every 30 seconds. So, if there's a change, it'll update every 30 seconds. So we'll see if it goes up again or if that's just a fluke. Very exciting. This is my first live stream. Figured what better time to live stream anything. Still sitting here. Is it gonna spike? This is very, very exciting. I know everyone's excited. Let's put these predictions down here. So then if I did the math right, then, we should see the long way second pass should be coming in tomorrow at like 11:22 here in Seattle. And who knows? Again, Krakatoa was seen 7 times, but using sensors from the 1800s, but that was a much bigger eruption. So now we have more sensitive sensors, but it's a smaller eruption. Not seeing any other major spikes. Keep waiting. The last time, it was kind of, sort of took its time going up. On the history plot, let's see, which one was that? That was the midnight one. Yeah, so it kind of took, from the beginning up to the peak was 10 minutes. So we'll hang out for 10 minutes or so and see if we see anything like that. Come on, pressure wave. And obviously it should be a smaller spike, but hopefully measurable. This is slightly less dramatic than I hoped. I need music. Well, let's see. For entertainment purposes, let me tell you about the sensor itself. It's just a homebrew weather and air quality measuring station. I actually have 2 of these, one inside and one outside. We're looking at the outside one at the moment. It's just, it's like one of these little Wi-Fi microcontrollers, an ESP8266, and then it's plugged into a bunch of different sensors, relatively cheap, that can all connect to the same bus. And so here's kind of a labeled version. So I have a sunlight sensor, motion sensor, accelerometers, hoping to catch, earthquakes or something. Temperature, pressure, humidity, volatiles, that's all embedded in this one MEMS sensor. And that's the one we're looking at right now, is this pressure, which is, and since I have 2 of them, one outside downstairs and one upstairs in the house, they go perfectly together, but just a little bit offset because the elevation difference, which is kind of fun. We have a particulate matter. Oh, look, the sensor went up. Folks, I think we might be seeing the second round here. I mean, we'll keep watching it for another 10 minutes, but I mean, it's certainly going up, and it's either just natural, the pressure changes anyway, but anyway, this is basically right on time. I can't say I hear it or feel it outside, but the sensor seems to be seeing something. Maybe we'll wait a few more clicks and see if it goes up. All right. What else is in there? I put a CO2 sensor in there so I can kind of monitor. That's actually more useful for indoor stuff, so that if you're cooped up inside, and you need to ventilate. So if there's a forest fire, it's interesting because you have to balance air quality with CO2. You close all the windows and then the CO2 goes up. The Geiger counter is not actually in there at the moment, but I'm hoping to put that in just because every environmental monitor has to have a Geiger counter. So anyway, there's links to all the different things I put, all the different sensors. Oh, and the rain sensor is actually really cool. This is one of these. They use these on fancy cars to tell you if the rain is coming down. It has like an infrared emitter and receiver, and it's always just sending infrared light around that little dome. And then when a raindrop hits it, that does some refraction. Some of the infrared light goes out, and so the receiver sees a reduction in infrared light, and it detects that as a raindrop. And so you can actually fairly accurately, not super accurate, you can really tell if it's raining or not, which is nice to go close the windows. And you can also sort of get a guess of based on how many raindrops you see, you can measure how rainy it is. And it actually matches the Seattle National Weather Service rain accumulation things super well, within a few percent, which is better than expected. Anyway, so I put in this box, put some fans on it. There you go. There's a fun little video of the rain sensor. So anyway, that's the sensor we're dealing with here. All right, let's see here. We're going to need another bump in this pressure if this is real. It's definitely going slightly slower than I expected. Not a huge steep spike. But anyway, I'm excited about it. Oops. Oh, look. Yes, we got another bump up here. So, I don't know, folks. I'm feeling pretty good about this. I suppose I would guess the pressure wave might sort of be more diffused as it's gone around the world the whole time. I don't know. I don't actually know much about shock waves going through atmosphere several times. Anyway, this is certainly kind of interesting. We should check let me check the indoor one while we're at it. Indoor pressure. Yeah. So you can see the same, definitely a big spike there. That's on let's just do today's history there. Yeah, so this is just, it's identical sensor, just a couple floors up. And that is also seeing a nice notable spike. So pressure is certainly increasing, and whether or not it's from the predicted pressure wave from the volcano or not, still to be determined. But I'm feeling like yes. Did we get another one? Yeah. Oh, yeah. Oh, it's spiking. It's going like crazy. So I was a little slightly early on my prediction. It went a little bit slower than I expected, but maybe I shouldn't have averaged the two waves. Anyway. So yeah, there's usually, it's kind of a classic shockwave type thing. There's a big spike and then a big depressurization as it passes by. So, and that actually takes a whole, from start to finish, it's like 20 minutes. Well, finish is actually way out here. So, geez, it's like 25 minutes. This is hopefully the most exciting live stream you have ever seen. Oh, geez. Oh, yeah. We got another spike there. Let me see if I can pull up the... This one isn't really giving us the live view here on the indoor sensor. By the way, this GUI is just Home Assistant, which is an open source home automation system that you can integrate all your different devices and stuff. It's very nice. So it's actually what's doing the plotting here. Indoor pressure. There's that. We'll get that graph going too. So there we'll kind of see, we'll see the two sensors go together. They should be pretty much aligned. Does this have a chat or what? Again, it's my first ever live stream. Oh, nice. There is a chat. Okay. Yeah, what's going on? Will humankind cease to exist? Yeah, no, humankind will not cease to exist from this event. This is just, there was a volcanic eruption a day ago, more than a day ago, and when you may see the shockwave spread out on the satellite picture. It was actually, you could see the shockwave on the satellite picture, and it turns out that with pressure sensors like we have today, and I'm just sitting here in Seattle looking at my pressure sensors, you can actually measure that pressure wave as it comes past you. So way up here in Seattle. So the first one came in yesterday at 4 a.m. and that was the one that was straight from Tonga to Seattle. And then there was another one that went around the world the other way, and that came in at midnight last night. And now we're looking for the second pass of that first direct wave. So it came from the volcano to Seattle and then all the way around the world and then back to Seattle. And we're just seeing if we can measure it. And there we got another bump up on the indoor pressure. So sure enough, here it is. We predicted with a little Python program, we kind of figured out how fast we thought the waves were going and the distance, and then we did a prediction. Whoops, that's actually the wrong script. We did a prediction that said we think the next wave will come by here in Seattle at exactly this time. And so here we are live streaming to see if indeed the sensors can measure it at that time. It's more of a curiosity than anything too serious. It's just a slowly growing pressure wave. So I would expect, I'll give another, I don't know, 5 minutes or so, 5 or 10 minutes, it should turn over. So we'll see how much of a spike we get. It's not super expensive. The sensor that I'm using is just this, let me go to the actual link of it. Where is it? Yeah, this thing, BME 680, is just a little, that I kind of cobbled together and put on this. This is a cutting board that I mounted everything on. And so the actual gas sensor itself is this little guy. But I got it packaged from this thing called Grove. So let's see if I can find the actual thing I got. BME 680. And they just kind of package it on a nice little chip and then sell it. And let's see, it really wasn't super expensive. I think it was like tens of dollars. $22. Unfortunately, it's out of stock right now. That's kind of sad. But it was $22. and then that goes into a little $7 ESP8266 microcontroller, which then, and this is sitting out in the house, and then it sends, that thing connects to Wi-Fi and goes into this Home Assistant, which reads and plots things. And look, we got another bump up. So these are still synced up, but I think that one bumped. So yeah, this looks pretty unnatural to me, or abnormal, I should say. It is natural, but well, anyway, I do think this looks like it is the wave passing by again. No, it didn't erupt again. It erupted. Well, it's been sort of an ongoing eruption, but the one big eruption is the wave from that eruption is traveling around the world, and it'll come around the world multiple times. And what we're doing here is just seeing if we can measure it the second time around, which is really, it's known that you can do it. In the 1800s, they measured Krakatoa go around, I think 7 times, I said earlier. And so now we're seeing in the modern day, can we see it with digital sensors, even though it's a much smaller eruption? This is fun. So let's go to this is kind of surprising, and it was when I read about this that I thought, oh, I should check the pressure sensors. Several barometers recorded the wave 7 times over the course of 5 days, 4 times with the wave traveling away from the volcano and 3 times traveling back to the volcano. So it rounded the globe 3.5 times. That's a stupidly big volcano, and there's all sorts of crazy stories from that eruption. And this one, of course, was just not that big. Let's see, where are we? Oh, okay, indoor sensor is still going up, so we got to boop up to 1020.5. So we'll expect the outdoor sensor to catch up pretty soon. Oh, there are reports on Twitter that there was another big eruption like a few minutes ago. Oh, really? Okay, well, then you're in the wrong Twitter feed. So let's see. So was there another big eruption? I have not heard that. Haven't been checking the news. Well, let's just try. No. Tonga volcano. 5 hours ago, 11 hours ago. I'm not seeing any new eruption news, at least here. Tsunami, WS. No new tsunami alerts, at least. Okay, 25 minutes ago, AFP does say another large eruption detected at Tonga volcano, according to Monitor. How about that? You're not kidding. How long does it take for an eruption wave to reach me? So it goes roughly just a little bit less than speed of sound, according to these measurements, at least. So it takes like 8 hours, about 8 hours to get from Tonga to Seattle. Is roughly what it does in that sort of direct route. So I'll have to do another live stream in 8 hours to see if we see that one. But interesting, I did not know. So as we're sitting here looking for the echo, or the first wave coming around a second time, it looks like that there's some reports of another eruption at that same volcano. So that's interesting, and that's not what we're seeing here. This is the first one. So again, because it takes at least 8 hours for a big shock wave at the speed of sound to get here. Interesting. According to Monitor. Surprised there isn't like a more they should link to something. Anyway. Alright, where are the sensors at? Uh-oh. This one, oh no, that's still where it was, I think. This is still, yeah, I think it was 0.5, 0.4. So we're still, maybe we're turning over at this point. We're coming up on the time that it should kind of start going into a steep decline as the shockwave has passed. It's not much of a shockwave at this point. You can see it's a lot less steep than the one at midnight last night. Watching slow graphs. Super exciting, I know. Anyway, well, I guess we should look more into this thing. See if we can find out any news. Yeah, just a bunch of retweets. Who monitors? You know who's good at this is the NOAA earthquake people. Let's see what they got going on. Does a volcano count as an earthquake? Hard to say. Let's see. USGS volcano events. Here's the USGS volcanoes doing something similar. They're saying here we can actually see the waves going by with their much more sensitive detectors. Yeah, and they aren't saying anything about the new eruption yet. So interesting. We'll have to keep an eye on this and see if you guys see any more information about this. That would be super interesting. Aha! And look, the pressure wave here is already going down on the outdoor sensor, and the indoor sensor. Yeah, it peaked at 5 and now it's going down. So we should see a much more rapid drop over the next 5 to 10 minutes, and that's really the characteristic of this second pass of the shockwave coming down. And I think if I had to guess, I guess it'll be a little bit less steep than last time, just because again it's diffused a bit. So we'll see. We'll see about that, but I think it'll be a little bit more exciting. If you can imagine it being more exciting than this, as it sort of drops. I'm guessing. Yeah, so they both just fell another one. These are going down real sharp. So we're down to 0.2 on the outdoor, 0.3 on indoor. So I think we'll see readings probably every 30 seconds this time. Last time it happened at midnight, we had 5:05, 35, 6:05, 6:35. So every 30 seconds it was dropping notably last time. So let's see if it happens every 30 seconds. 0.2. Just wait it out. Yep, there's another This is down to 0.2 now. So down it goes. Shock waves, my friends. And again, I mean, I would never, this is totally not perceivable. Obviously can't hear it, can't feel it. I don't know if anybody's like ultra sensitive to air pressure changes, but even I doubt they would be able to feel. I mean, some of these changes are somewhat notable. Like this drop is fairly significant, so maybe like a super sensitive person could feel something in their sinuses or something like that. But really, it's just something that real sensitive sensors can detect. Yeah, it's going slightly slower than last time, so I guess that's sort of as I guessed. We should see this go down to 0.1 in the next 30 seconds or so. Yep. So again, if anyone's just joining, we are looking at the second pass of the first shockwave around the world from the Tonga volcanic explosion that happened a day and a half ago. We detected the first pressure wave 8 hours after it hit, or after the eruption went off. That shockwave made it to Seattle, and it made a clear reading. Oh, there we go, down to 0.1. So yep, there's the depressurization. Anyway, and then that shockwave kept going and went around the world and then came back, and now we've predicted that it would come at 3:53. Is that what I said? What was my prediction? 3:53. We thought it would start again, and so we started live streaming right then to see if it would happen, and it pretty much did. We see a small spike here, and then so we're seeing the same characteristic: compress, decompress, and that's exactly what we're seeing here, and it's very exciting to be able to measure in our own home with cheap, $20 equipment. We can actually detect that there was a big volcanic eruption, several days ago, and now the pressure wave is going around the world. It's very interesting. We got some, so back up a little bit, and that could be, there's variations and whatnot. It's not super surprising to see it go up a little bit. It'll keep going down in general, I believe, well below what it was before. So, we can kind of predict maybe it goes down to, it'll certainly go below 1020. Yeah, and we saw some reports that there has been a second or a more recent explosion. We just saw that on this here, but I haven't seen. I'm kind of hoping for more more information about. Here we go. Something set off the buoy system. So anyway, it sounds like there is another eruption, which we aren't detecting the new eruption if there is an eruption, which it looks like. I mean, at least there are reports of it. That shockwave won't make it to Seattle for another 8 hours, at which point we'll have multiple origin shockwaves traveling around. We already have two from the original eruption, because there's the one, when it first erupted, they started moving out concentrically, and so the first one hit, and then that second one that came the long way was also measured, that we saw last night. That's actually this one. And then, and now we're seeing the first one pass again. So very exciting. If the shockwave is so big, then why won't it fight me? I mean, yeah. I assume you're outside yelling at it, to bring it. Great question. So, yeah, I wonder if there's another. Can we search for trending or something? Latest. Another large eruption has been reported. I'd love to see something from. I don't know how long it takes. Oh, here we go. How long it takes the National Weather Service people and to mention these kind of things. All right, so let's see. This was at 9:19 Zulu. Let's see, what time is that? It is currently, or sorry, yeah, 9:19 Zulu. It's currently midnight 23 Zulu, so that was a different, I think that's a different, yeah, that's from the original. This is from the original eruption, I believe. How are we doing on the sensors? All right, still, it's not falling off too fast. Let's check the other one. Whoops. All right, so this one's coming back up. So this is so far it's a significantly less dramatic fall off than the one we saw last night. So that's sort of interesting. Not nearly as much of a drop as last time. So it's just sort of diffused as it went around the world. All right, still reading about eruptions. Come on. Who does these things fastest? Yikes. Another one. Let's see, what does this say? Translate. Images of the new eruption in a volcano in Tonga. So this one is saying it's perhaps the more recent eruption. It looks pretty significant if that is indeed the new one. Holy cow. That volcano's going crazy. Anything else we're seeing? Here's one. Let's see, what language is that? I'm not sure. Turkish. So the third largest volcanic in the 72 hours. Many countries in the region, tsunami gave the alarm. Here are the images. I wonder how big it was. Interesting. Wow. Oops. Yeah. Captured just 30 minutes ago. This says there is there is eruption. Is that what that says? My Spanish is rusty. False news of major eruption is circulating. However, they do not show anything. Okay, well, I mean, conflicting stories. Again, I'd love to see some sensor data before someone should link to a sensor that shows the thing going off. And that video could be the video from yesterday as far as I know. So anyway, I still haven't seen it like totally confirmed except by a couple quasi. Anyway, I don't know. You can read Twitter as well as I can. Anyway, what we're really doing is looking for this shockwave here from the previous eruption. Look, now it's going back up. This is really unexpected. So, yeah, interesting. So the big drop off again, we're just really not seeing it. So it might be. I was hoping we'd see like a really big drop off to really sort of say like, yep, we saw it come by a second time. But maybe I have to give another 10 minutes and see what the shape looks like. So anyway, again, and I'm sorry if I'm repeating too much, but we are back in 1883 when Krakatoa went off. They were able to measure the pressure shockwave going around the world 7 different times, which is super interesting. And so what we're doing here is we're looking at live sensor readings in Seattle, Washington, where yesterday at 4 a.m. we saw the first shockwave easily seen on our barometer, and then we saw the long wave shockwave last night at midnight. So that's one coming straight from Tonga to Seattle, and the other one going around the world, and then coming to Seattle the back way. And so then, based on that and the time of the eruption, we predicted with a little program here written in Python. Program here. Sorry. Edit. So we wrote a little program just based on the coordinates of Tonga and Seattle. We put in the time of the eruption, which was 4:14 on the 15th UTC, and then we took what time our first wave and our second wave came in the Pacific time zone, and then we computed the distance, and then based on that, we computed the speed of the wave, and then we were able to then predict by adding, for 7 different loops, circumference of the Earth times what loop number you're on divided by the speed of the wave, and then that actually gives us these predicted times that the shock wave would come back through Seattle. And so here we're sitting at the second pass of the shortwave shock wave, based on this program, was predicted to come to Seattle at 3:53 p.m. today, which is when we started the stream. And so we think we've seen it on our sensor here, but it's definitely a lot less pronounced than the one last night. So as it went around the world, it got all jumbled up. So that's pretty interesting. We made, based on how small this is, will we see the second long way one tomorrow at 11:22? I don't know. I think it's certainly possible that we won't even be able to measure it at that point, but worth trying. How strong was the first eruption compared to a nuke or something? I actually don't know. That's a great question. Nuclear explosions are usually measured in metric tons of TNT equivalent, and so so like a big thermonuclear blast is a couple million tons of TNT, megatons as they call them. So like 3 or 5 megatons. The biggest ever was 50 megatons, the Tsar Bomba. I'm not sure like how the volcano scale is on a different scale. They have this like V something scale that I don't know how it compares to tons of TNT. That's a good question. Compared to megatons. Let's see. I mean, the big volcanoes like Krakatoa are dramatically more bigger than the biggest nuclear weapon. So let's see. Assuming self-employed David Brownie here is correct, and this sounds right. St. Helens was a V5 significant, blah, blah, blah. So it was like a 24 megaton nuclear explosion for a small volcanic eruption. Well, medium at least. Actually, I believe this Tonga one is a VEI5, if I'm not mistaken. So that's on the order of like the biggest nuclear explosion of all time. But then when you get into the really big volcanoes, those are more like bigger than the biggest nuclear weapons. And then here we go. These guys are 800 megatons. So that's 20 times the biggest nuclear explosion of all time, which was already 10 times bigger than a normal nuclear explosion that you have in a typical military inventory. So volcanoes are bigger and more powerful than nuclear weapons in general, especially the really big ones. Again, on the sensors, it's just jiggling around. So maybe we just won't see that big depressurization dip like we saw last time, and it's just kind of skipped right over it into this area. I'm not sure if that's expected or not. I definitely thought it would go down a lot more, so this is a little bit surprising. Let's see, how's the news developing? Is there actually another eruption or not? Trending. Yeah, I don't know. What are like trustworthy news sources? Yeah. So there's definitely a few reports of another eruption, but yeah, where's the data? I see no sign on. Yeah, this is good. So I don't know how delayed these image viewing satellites are, but it sounds like people aren't seeing any sign of a new eruption on those. So once we see images, on these satellites dated, in the last half hour, then we'll see if there's a new eruption or not. But I don't know. I could certainly imagine that just being like a thing that people start seeing. But we have all these sensors, so let's just see some sensor data, and then we'll make the conclusion. Now imagine Yellowstone blowing up. Yeah, Yellowstone. The super volcanoes certainly be big. And then of course there's asteroid impacts, which are even much bigger. If you've seen everybody's favorite latest Netflix movie. Huh. Yep. And now just kind of going up and down. So I don't know, maybe this show's over. No big dip. I guess we'll have to I'll have to come back online, or to check back in at 11:22 tomorrow. And we'll see if we see anything. But at the moment, I don't really see much. Anyway, well, I say I'm going to claim that that my math from this program is right. It's pretty simple. And I had Python do the time zone conversions. And I think this probably was the sign of that wave coming around the second time all the way around the Earth. It's not super impressive or dramatic, and I'm not 100% sure that that's it, but I want to believe, and I mean, it's a pretty notable spike, bigger than any of the other, well, sort of on par with that spike. But anyway, yeah, I think that may have been it. And I'll check back in. I'll watch it over the next little while and post an update or something, and then maybe come on tomorrow around lunch and see if we can do it again. But I think I better just wrap it up for now. This is my first live stream ever. I hope it was fun. I had fun. And thanks for joining. So have a nice day. Bye.